Hello everybody and welcome back to Juno, where we are currently working on this drive around for 5 kilometers contract. I've already gone 4.62 just by driving in a circle here. So I would turn around here and then drive back over to here and then turn back around. And I did that a lot of times. So now we are ready to get the last little bit here. Excellent. So let's get this wrapped up. I don't want to get air as we go down here. I want to remain grounded. But now we can just accelerate down the runway, and this should definitely be enough distance to get us this last little ways. So we're 4.83 right now, and we are definitely going to get what we need very, very swiftly here. There we go. Contract completed. So let's bring this to a halt, end the flight, recover the craft, and there we go. Fantastic. So there's that contract completed. Now, just before I started this recording, we also got a land distance record of 10 kilometers, which gave us some extra tech points as well. So let's hop into the tech tree and see what let's see what our next mission is before we decide what we want to do. So we've got light speed here, go faster than 2 kilometers per second, reach 80 kilometers at sea level. So 2 kilometers per second after 80 kilometers at sea level. That's basically the same as Drew Orbit, right? This contract has a tutorial, and I don't know if we'll... I'm actually curious to do this because we need to go to orbit, right? And in order to do that, it's almost certainly going to have us do liquid fuel. So signing bonus of 80k, yeah, look at how much more money this is. This is definitely going to be liquid fueled. So I think we'll do this tutorial, but I'm going to accept this contract because these two are the same thing. It's literally the same thing. So we might as well do both at once. I'm going to accept this contract, and then I'm going to accept this contract, and then we're going to start the tutorial and see what it wants us to do. Okay. So how does it want us to achieve orbit? We have a craft ready for you to use, but it needs a few tweaks to its engine. So it's just going to give us this craft. Okay, so we see that this is an interstage here. This is an interstage here for some reason. It definitely does need some tweaks. So this is the craft's total delta V, 6.16 kilometers per second. Okay, sounds good. Realistically, we need at least 4,500 to get into low orbit around Drew. That's good to know. That is definitely a slightly different number than KSP. That's fine. It appears that we have more than enough, but we also need to consider that engine performance is affected by atmospheric pressure, which changes with altitude. Yes. So we need to change the altitude to 0. And we can see what our starting thrust to weight here is. Thrust to weight is still pretty decent, but our delta V is much lower. Yes, we have some work to do. We'll need to look at each stage to see what we can do to improve performance. Don't worry, it's just rocket science. That is a very relatable statement right there. It's just rocket science. It's not a big deal. Okay, so we're going to look at this first stage, which has 5 solid rocket motors. Okay, select stage 1 in the design info panel. The fuel tank? No. I guess we need to do... This is a design info panel here. Oh, we're in all stages here. We need to go to stage 1. So we can see that stage 1 is 679 meters per second. The delta V looks okay for this stage. Yeah, that's what I was thinking. We need to use it to gain altitude before starting the more efficient engines. Yeah, that's exactly what I was thinking. Another important metric to consider is the thrust to weight, which we already looked at. 1.79 sounds good to me. Yeah, this stage has plenty of thrust to weight for launch. Note that the ending thrust to weight is higher than the starting. That's because it burns the fuel. Yeah. That's fine. One last thing to mention is the specific impulse. Yes, so that is essentially the efficiency. It's kind of like gas mileage for rocket engines. Higher is better. Yeah, they're not very efficient, but they're cheap and they get the job done. So 148 seconds of specific impulse is not great. That's for sure. And they're just intended to get us off the ground. Let's look at the second stage. So, from our previous launches, we found that this stage will ignite around 8 kilometer altitude. Okay, so this will be around here-ish. Okay, so we need to select stage 2, and we can see 784 meters per second. That is not much thrust to weight here. The delta V and starting thrust to weight is terrible for this stage. Yes, this is because the Gnome engine is optimized to work in a vacuum, but don't worry, we could do some rocket surgery here and improve its performance inside an atmosphere. This engine is suffering from severe overexpansion. Ah, yes, the exit pressure. So we're going to have to actually adjust the nozzles. Fascinating. I imagine aerospikes are going to be really good in this game. Okay, overexpansion is what causes shock diamonds to show up in the exhaust. The closer exit pressure is to air pressure, the more efficient the engine becomes. Okay, so we can see here that the exit pressure is 3.67 kilopascals, and the air pressure is 38.5 kilopascals. That's not amazing. We can shorten the nozzle and crank up the power to increase this engine's exit pressure so that it's closer to the air pressure at this altitude. I'm glad we ran this tutorial because it's teaching us how to create like custom engines. This is very good. So we need to choose the engine part here, presumably, part properties panel on the left. Right, we need to open up this bad boy. Okay, so the throat size and the nozzle length. Right, we can shorten the nozzle and crank up the power to increase its exit pressure so that it's closer to the air pressure at this altitude. So we need to change the throat size to 100%, and let's keep an eye on what this does to our exit pressure. That's definitely raising that exit pressure. So that's now 7.81 kilopascals, but that needs a lot of work still. And then we need to change the nozzle length to 50%. And that's also increasing our specific impulse. Okay, that's definitely noted. Now, this is way too much exit pressure, I think. Let's see here. So what is our overall delta V in this stage? Yeah, 1.57. Yeah, that's definitely the case. Technically, if we wanted to optimize it, it would be somewhere around here at like 20%, I think, because this is about where we're maximizing our delta V for the stage. Our thrust to weight is 0.93, which isn't great, but as that burns fuel, that would go up above 1 pretty quickly. I think that this is probably the actual optimal position, but the game wants us to put it at 50. And we can see a shock diamond forming there. Okay, that's neat. So the exit pressure is still 22.4 kilopascals. So maybe it would be because of the size of the rocket engine. Probably. So we need to crank up the power at this point. And this is definitely boosting the cost of this, so that's noted. We want to put this up to 80%. Okay, so at this point, 1.55 kilometers per second. This is less efficient than what we had before. Okay, that's noted. We can also have bell nozzles or other nozzle styles. That's interesting. All we have right now available is bell, so that's fine. This is pressure-fed power cycle, Carolox fuel, and a liquid-fueled engine. Fascinating. Okay, so we can close the panel at this point, and that's a huge improvement in delta V and thrust to weight. Now let's take a look at the third stage. Okay, so up over here we've got this third stage. This will be mostly working in the upper atmosphere and in space. So we need to change it to vacuum, and we need to change to stage 3. The delta V is pretty good for this stage, but we can improve it by lengthening the nozzle. That would make sense, because this is a vacuum-optimized engine. Okay, ideally exit pressure would be 0 for a rocket engine designed to work in space, but that would require an infinitely large nozzle. We'll have to settle for something a little shorter than that, fair enough. So this is all fine. We need to make sure that this engine is selected. We want to set the size to 35% according to the tutorial. So let's keep a close eye here. 3.25 kilometers per second and 266 seconds of specific impulse. The starting and ending thrust to weight are absolutely fine. So let's keep an eye on that. So sizing down this nozzle is not really changing too much, although it is increasing our thrust to weight. Technically, like here would be the best in thrust to weight, or rather in delta V, but the thrust to weight is not ideal. So 35 makes some amount of sense. We're just over 1 thrust to weight here, so that makes sense to me. And now we need to set the nozzle length to 160%, which is increasing our specific impulse. Yep, I like it. Cool. And then we are apparently done with this engine. So that definitely boosts up our delta V here a little bit. Thrust to weight looks good across the board. This is really nice to be able to have this kind of granular control over your engines. I'm gonna really like that. Okay, so let's close that, and this rocket is now ready for launch. So at this point, we need to click the launch button, and we're going to put this not on the runway, but on the village pad. Okay, so now the question is, how are they going to have us actually orbit? So click the button on the right side of the screen to show the nav sphere panel. Click the lock button, lock heading to enable heading lock. Okay, so we're locked on the current heading, and that's just going to bring us straight up. Which I guess makes sense because we just want to get as much altitude as possible out of our SRBs, right? So our solid rocket motors are going to get us as high as they can, which is going to be somewhere around 10 kilometers, or they said 8. I'm assuming they mean at sea level. So that's going to lift us up to there, and then I'm assuming, because this is an orbit tutorial, I'm assuming it's going to have us change our heading to go eastward. Probably, it might just lock us to prograde. We'll see what it wants us to do. Let's see how it wants to achieve this. There are multiple ways to achieve orbit. Some are more efficient than others, and this will probably be a decent one. We'll see. So let's go. Off we go, decent thrust to weight on those solid rocket motors. Your next step will happen around 6 kilometers at ground level. Okay. But it should be at like 8 kilometers at sea level. And sea level altitude is what I'm concerned about right now. That's how atmospheric pressure is usually determined. Cool. So we're going to stage as soon as we run out of fuel. And then are we going to start a gravity turn, is the question. Our thrust is definitely going down a bit. 3, 2, 1, and out of fuel. So we can press space to activate your second stage. Remember to throttle up this time. It's no longer a solid motor. I will throttle to max with the Z button, which I just tried for the first time. It works. So very similar to KSP in that regard. Cool. Okay, click and drag anywhere on the blue nav circle until your pitch is set to 70. Okay, so they're targeting 70 degrees. Sure. That seems fine. This should be 70. There we go. I assume that this engine is gimbaled. It doesn't actually say, but I assume that that engine is indeed gimbaled. Your rocket will now start tilting. This is important because to be in orbit, you need to go sideways very fast. That is accurate. Altitude is only important insofar as you need to get out of the atmosphere. Otherwise, you got to go sideways. In fact, yeah, okay, so now it wants us to lock velocity prograde. Sure, that makes sense. You can build your rocket to follow a natural gravity turn. I usually don't. This forces the rocket to pitch down as it goes up, following an efficient path to orbit without the need of complex guidance systems. Yeah, I usually just manually do it. No, let's not close the tutorial, though. I'm still interested in seeing what we've got going on here. So we're waiting until the fuel in this stage is completed. Makes sense. I kind of want the nav ball open. I want to see what we've got going on here. Yeah. So we're just locking prograde at this point, and this is just designed to follow a natural gravity turn. I don't usually do that. I usually force it into a gravity turn. It's not the most efficient thing in the world, but it's fine. This is only rocket science, right? It's not a big deal. Okay, so 4, 3, 2, 1, 0. Now it's going to want us to stage. Excellent. Now we're still in atmosphere at this point, so we are not at peak efficiency at this point. And we're targeting our apoapsis being greater than 150 kilometers. Presumably it's going to have us set up a circularization burn once we reach 150 kilometers. Okay. Press the X key to kill your throttle immediately. Yep, exactly like KSP like that. And you can set up the speed of the time in the game to reduce waiting times. Yeah. So now it wants us to set it to 10 degrees. Okay, that's absolutely fine. We can do that, and this is going to be trying to get us a bunch of horizontal velocity, but we're not going to burn this until we reach our apoapsis, or perhaps apogee. Sure. So that's fine, and then we want our heading to be set to 100 degrees. Interesting. I wonder why we're setting our heading to 100 degrees. to compensate for the rotational velocity that we picked up in this inclination, perhaps? I'm not 100% certain why it wants us to set our heading to 10 degrees. That's not necessary usually, but this isn't an equatorial launch site. So I guess that might have something to do with it. So we can speed things up, that's for sure. And we've got a few seconds here. Yeah, this is giving us a timer. Wait until you're just 10 seconds away from it. Yeah. So it's just having us set up a burn here. And I kind of don't want to press and hold left shift. I'm going to press Z here. But it wants us to perform a burn here to circularize. We need to raise up our periapsis at this point up to at least 80 kilometers. Okay. Yeah, we need to raise our periapsis, the lowest point in the orbit, until it's higher than the atmosphere. That way you won't touch it at any moment, keeping you in orbit, in theory. I mean, that's not quite how it works in reality, but it's pretty close. Okay, so we need to get ourselves up to orbital velocity, and the question is, what is orbital velocity in this game? But I am betting it's greater than 2,000 meters per second. At any rate, we're definitely going to go greater than 2,000 meters per second. Now, where is our indicators of what our apoapsis and periapsis are? That is not currently on screen. Maybe we need tech for that. At any rate, we're just going to continue to burn here. We can see we are going down at this point, but I'm guessing in KSP it's around 2.3 kilometers per second. It's probably something fairly similar in this game from what I've seen. The delta V requirements seem to be broadly ballpark similar. So let's just continue to burn here, and I guess I now understand why it's having us be at 10 degrees here, because this is technically, if I pause the game here, this is technically, wait, it didn't pause. It says paused here, but it's not. We're actually still going. Okay, so light speed has finished. Yeah, this pause isn't actually working. I think the tutorial is overriding it. But this is because we are burning a little late, is the answer there. So our periapsis is currently minus 600 meters. Okay. We're counteracting gravity here, but we definitely burned late. 3,300 meters per second in order to get orbital speeds at this height. Okay, so that's definitely higher orbital speed than in KSP. No doubt about that. Our periapsis is going to be going positive very, very soon. There we go. It's now positive, and we are over 80. I'm going to shut down the engine. We've got 13% fuel left. We could return this, but there doesn't seem to be much of a point. So we achieved our first orbit around Drew, and now that you've reached orbit, you're going to be asked to get to precise orbits. Let's see how that is done. In order to adjust an orbit, the easiest way is for the craft to be in its highest or lowest point. Yep, and adjust one thing at a time. To adjust the apoapsis, you want to be in the periapsis and vice versa. Yeah, but how do we actually see that? Since your apoapsis went a tad too high, the orbit is very elliptical. Let's try to make it more circular by waiting to be in the periapsis to lower it. Okay, so we want to lock velocity retrograde, and then we unpause. Yes, this makes sense because we need to position... Yeah, there's definitely a gimbal on there. We need to position ourselves for retrograde, but that's going to be different when we get around to where the periapsis is. For now, let's just follow our way to the periapsis. It's going to be about 7 minutes. Sounds good. And we're going to try to adjust our apoapsis, but I'm still unclear how we see our actual orbital info. I think we have to do it in the map view, is my guess. That's the current theory, because there's definitely orbital info in here somewhere. I guess we can see it here. I'm assuming the tutorial will auto-pause us. Yeah. Press and hold left shift to throttle. This remained on the periapsis. That's interesting. So it doesn't drift like in KSP. Okay, press and hold left shift to throttle up to 30%. Okay, so 30%. There we go. And we can unpause. And we're looking to, I think, circularize this. Apoapsis less than 95. Okay, yeah, that seems fine. Cool. And I cut the throttle, and at this point, we've completed the contract Drew Orbit. So both of these contracts are completed. Excellent. So we can see our location here. That's nice to have. KSP doesn't have the latitude and longitude there. This is, of course, the sphere of influence that we're in. Apoapsis, periapsis, time to apoapsis, time to periapsis, gravity, but it does not include inclination information. That's interesting, for sure. Okay, noted. Well, let's end this flight and let's head on back. So we're going to not be able to recover this craft. I believe that we are just going to scrap it. Yes, it's not on the ground. That's okay. So we completed 2 contracts in one go. I love it. And now we've got this going sideways craft, 100 kilometers away from the village. 100K to do this. That craft that we just did is 93K. So we should not use that same craft, although it would certainly be capable of it. Okay, and fast roller is timed. Going sideways is not, nor is Juno Peak. So we should probably do fast roller here. 55.6 meters per second, huh? Interesting. Tech points if crewed. 10 tech points. Well, that's interesting. And then this one is just go up to the peak. Again, tech points if crewed. I'm not sure which peak we need to be at, and we need to bring a camera, and apparently we need to bring a crew member. So that is definitely noted. 55.6 meters per second is a fair amount of meters per second, but that seems like a viable thing. So let's accept this contract for now, and let's go into our build. This rocket, I think that we're just going to throw away. It's not one of my designs, so let's get rid of that for now. Let's just create a new craft, and I want the orientation of this craft to be in plane orientation. We're going to put in a Druid. Okay, so that Druid is, you know, kind of big. That's noted. We've been building very, very small vehicles up until now. So we're probably going to have to increase the size of this. I'm wondering, is there any real way... That's a drogue chute. I think we're going to need some tech. Let's exit this designer. This is a terrible craft. I like how the Druid is just sitting there staring at a floating disc. That is amazing. We need some sort of, like, chair or pod. That would be a decent thing to have. Fasten your belts, crew limit, and chair. Okay. That's probably a good thing to get for him. Cool, so that sounds good. And then we've got some things up over here that we are probably interested in. But I think for now, we might want to consider getting Racer. Okay, that'll do for now. So now we're going to want to go in here and we're going to want to figure out exactly how this works. So we can throw in a fuel tank here. And then we can give this guy a chair right up on top. It'll be very safe. We also are going to want a camera on here. So let's do that, but I'd like to flip it around, not in these directions, but rather this direction. There we go. That'll do for now. And where's that chair at? Here's a chair. Okay, so we're going to put a Druid up on top here. And again, I want this flipped all the way around here to be facing forward. And can we put him in the chair? Yes. Perfect. So that looks fine. Now we're going to need some wheels on this thing. So we're going to go with car wheels. This is going to be a very safe contraption, for the record. Very, very safe indeed. I'm going to scale this down a little bit. I want to attach this here. Turn him around. There we go. And then this guy, of course, is also going to have to be scaled down. Something about like that. Then we're going to put these wheels on here. I'm going to do a set here, and then right-click to duplicate. A set here. Okay, now we're going to go into symmetry mode, and we're going to go into mirror symmetry. There we go. And we're going to be starting with something very, very similar to this. Okay, so we're going to have a camera on here. The primary goal of this is going to be, this is not the angle that I wanted at. I guess that'll do. The primary goal of this is going to be to climb up to the peak. And we might want an additional set of wheels for that. I don't know. We'll see. We might also want to make these wheels be a little bit wider apart. That is all something that we can think about doing. Actually, a structural panel is probably a good way to do that. So I'm going to take this off here. We're going to put a structural panel on here. Do we want it to be this long? Maybe not quite that long. It likes to snap like that. Interesting. This is behaving very strangely. Okay. There we go. Something kind of like that. This guy wants to move sideways, though. So what one do we actually need to move to change the length of this? That's interesting. Yeah, that doesn't work. This one moves around like this. Huh. Well, that'll work for now. And then we can just attach this guy on here. About like that. I don't love that positioning. So we could put it about there. Okay. And then we could get rid of this. Duplicate this. Like that. I keep trying to alt-click. This is not Kerbal. Okay. 60 is not the correct angle, but that is the correct angle. Okay. So something kind of like that. Then we can choose the part symmetry mode, select this guy, put it in mirror mode. And then we would apparently also need... this is not, I guess, connected correctly. Okay, there we go. Something like that. That'll be a little bit more stable, but this is going to be... We're going to have to do some testing on this one. This is going to be interesting. At any rate, it is time to put a cut in here, so I'm going to go ahead and do that. We're going to save this as car, all caps. This is definitely a very real, very normal car. No doubt about that. We're going to save that for now, and we're going to do some additional tweaking on the motors on those wheels. We're going to need a power source. I wonder if we could just attach that to the rear of the chair. That could be interesting. But this is going to need a little bit more work, and we're going to see about making it up to the peak of that mountain. You can leave your offerings to the engagement gods in the form of likes, comments, subscribes, and bell ringings. This is a very blunt nose here, and it probably shouldn't be. You can, that's something we'll be looking to change. In fact, I'm going to do that right now that I'm thinking about it. We're going to need to flip this guy right on around, like that, and then I'd like to attach it, boom. There we go. So that'll be a little bit better aerodynamically, I'm sure. As I was saying, you can leave your offerings to the engagement gods in the form of likes, comments, subscribes, and bell ringings, and a very special thank you to all of the channel members for making this video possible, including ALS Gamer, Atala, Ali Lee, Dark Horse, Xenocyte, Upper Cumberland Gamers, Nick Smarty, Dimitri H, Punching the Microphone, The Lounge STL, Kentogan, and all the rest. And of course, you. Thank you for watching. If you'd like to support the channel, you can click the join button down below the video, and as always, I will see you all next time.